Good morning everyone, very good morning. Today we will discuss about quantum numbers. See, quantum numbers. In an atom, large number of orbitals are designed. The large number of orbitals in an atom, the large number of orbitals are permissible. In an atom, large number of orbitals are permissible. These orbitals are designed by using three set of quantum numbers. So, actually orbital means it is the maximum probability of electron present around the nucleus. The maximum probability of electron present around the nucleus is known as orbital. So, orbitals are, so many orbitals are there in an atom. So, a large number of orbitals are permissible in an atom based on the three set of quantum numbers. Based on quantum numbers, the orbital's shape designed, the orbital energy levels are designed, the orbitals are spatial orientations are designed. These orbitals are designed by using first mainly three quantum numbers, that is, one is principal quantum number, one is principal quantum number, two azimuthal quantum number, three magnetic quantum number. And after these three quantum numbers, to explain spin of the electron, another quantum number also designed, that is known as spin quantum number. This is fourth quantum number also designed. The fourth quantum number is known as spin quantum number. To explain the energy of electron, to explain shape of the orbital, to explain orientation of orbitals, to explain spin of quantum number, spin of electrons, four quantum numbers are majorly required, but before spin quantum numbers, three quantum numbers only proposed. That is, one principal quantum number, two azimuthal quantum number, three magnetic quantum number, four principal quantum number. Now see, check, one is principal quantum number, first one, principal quantum number. The principal quantum number designed by or introduced by Bohr, introduced by Niels Bohr. The principal quantum number represented by letter N, it is represented by N. The principal quantum number represented by letter. And 3, it have it contains some numbers. It have 1, 2, 3, 4 integer numbers. The 1 means n is equal to 1. It is first shell. It is also represented by k. N is equal to second shell. It is also represented by L. N is equal to 3, third shell. It is also represented by M. N is equal to 4, fourth shell. It is also represented by N, KML shell. The values of principal quantum number 1, 2, 3, 4. Okay, these are called values, N values. See, it has n values 1, 2, 3, 4 and etc. And the principal quantum number indicates main energy levels. It indicates main energy levels. Main energy levels. So, main energy levels means, for example, if you take an atom with nucleus, after nucleus this is first shell. First shell means first main energy level, and it is a second shell. Second shell means second main energy level. It is third shell. Third shell means third main energy level. Like that, away from the nucleus, we have n values increases. So, n is equal to 1, n is equal to 2, n is equal to 3, like that. So, here increases, n value increases. The n value increases means the size of atom also increases. See, n value increases means the size of atom increases. Why? Because if n is equal to 1, this is the radius of orbit. This is the radius of orbit, the radius of shell. If n is equal to 2, shell radius, n is equal to 3. So, with increasing the n values, n1, n2, n3, the shell numbers increases. Shell numbers increases means size of atom increases. Size of atom increases. The size of atom increases means only we can explain the size of atoms based on principal quantum number only. The size of atoms explained based on principal quantum number only. So, here principal quantum numbers n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4 and so on. Okay. So, to explain radius of atoms, we are required principal quantum number. For example, we have also formula to explain radius of atom based on Bohr's theory, that is Rn is equal to n square 0.529 angstroms. For example, in hydrogen atom, if n is equal to 1, R1 1 square 0.529 angstroms, that is equal to R1 is equal to 0.529 angstroms. N2 R2 2 square 0.529, that is 4 into 0.529 angstroms. Then it is, if multiple with 4, 36, 3, 8 and 11, 20 point angstroms. So, from the radius in hydrogen atom, this is the radius of orbital, that is 0.529. If we take n is equal to 1 shell only, If you take another n is equal to second shell, see like this, first and second, this is radius, n is equal to 2. Then what is the radius here? 2.116 angstroms. Based on radius values, we can explain the size of orbitals. With increasing number of cells, n value increases, radius of orbital also increases. Radius of orbit also increases. So, radius of orbit increases means size increases. So, the mainly principal quantum number explain the size of atom. This is very important. And about another important point based on principal quantum number, I will explain, that is known as about specification. So, the based on principal quantum number, it is also gives the number of main energy levels is equal to n. Main energy levels is equal to n. Say for example, if we take n is equal to 3, it contains 3 main energy levels, 1, 2, 3. 1, 2, 3. Second point, it is also explains the number of orbitals present in main energy levels, that is n square. For example, if you take n is equal to 3, that is n square means it is 3 square. 3 square means 9 orbitals present. 9 orbitals present. That is 9 orbitals present means, like if you take third shell, what happened? We have third shell 3s. It is only 1 orbital. And 3p, it contains 3 suborbitals. And 3d, it contains 5 suborbitals. D contains 5 suborbitals. S is only 1 orbital. P contains 3 suborbitals. And D contains 5 suborbitals. Here 1, here 3, here 5. Add total 9. See here, in based on principal quantum number, we can explain number of orbitals present in main energy level. Number of orbitals present in main energy level. And it is also explains the total number of electrons present in main energy level. The total number of electrons present in main energy levels, that is 2n square. The total number of electrons present in main energy levels, that is 2n square. So, if n is equal to 3, then 2 into 3 square is equal to 18. So, 18 electrons present in third shell. So, 18 electrons present in third shell means, for example, take from n is equal to 1, n is equal to 2 and n is equal to 3. See how many electrons present in third shell. Third shell means the n is equal to 3 contains 3s orbital. It is like 3p orbital. It is 3 suborbitals, 3d orbital. It is 5 suborbital. Each orbital accommodate how many electrons? 2 electrons maximum. See here 2, here 1, 2, 3, 4, 5, 6. Here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here 2 maximum electrons. Here 6 maximum electrons. Here 10 maximum electrons. Total 18 electrons. This is also explained by n value only. So, hence the principal quantum number also explains the total number of electrons present in an orbit. That is formula 2n square. If you take third shell, 2 into 3 square, it gives 18 electrons. Understood? The 18 electrons present, that is 2 into 2 square. If you take third shell, total number of electrons present here, third shell is equal to 2 into 3 square is equal to 18. This is our. And the principal quantum number also explains the last point, angular momentum of electron. Generally, angular momentum of electron is equal to mvr is equal to nh by 2 pi. Here it is also depends on n. If we take first shell, mvr is equal to h by 2 pi. If we take second shell, the mvr is equal to 2h by 2 pi. If you take third shell, mvr is equal to 3h by 2 pi. So, here generally take 1 by 2 h by 5, 0.5 by pi. Here h by pi only. Here 1.5 h by 5 only. Like that the values increased. 1 electron means that is 0.5 values increased to the angular momentum of electrons. So, in today's class discussed about only principal quantum number. It is the principal quantum number is very important, because the main energy levels are only based on principal quantum number. The principal quantum number is represented by using n. So, n value, based on n value you can explain lot of points, because if you know n is equal to 1, it is one shell, that is first shell, n is equal to second shell, n is equal to 3 third shell, n is equal to 4 fourth shell. So, total number of cells present around the nucleus, that is known as infinite. We can take infinite number of shells, but based on first, second, third shells we can explain their energy of orbits, and also the size of atom, the radius of atom, and also the number of orbitals present in the shell and the number of electrons present in the shell, and we can explain angular momentum of electrons. So, these points are very important for like principal quantum number. So, generally in principal quantum number, for example, here we can write 3s orbital. So, 3s means 3 means ns, where n is known as principal quantum number. If you take 2s 2p orbital, what is n? Here n is equal to 2, that is known as n is equal to 2p orbital. It is p orbital present in second shell. Sometimes they will give 5d orbital. So, fifth orbital present in, d orbital here present in fifth shell. So, here this is represents n value. N value means that is based on principal quantum number. So, students, first of all read concept and listen concept carefully twice or thrice. After that we can do any objective type bits in JEE Mains and NEET or any other competitive examination. So, it's this concept, quantum number concept is very important. So, please see the video properly and answer the objective questions. Good day, bye.